So if I were to sum up interaction design in a sentence, I'd say that it's about shaping our everyday life through digital artifacts for work, for play, and for entertainment. When we go out and buy something for our house, we don't just buy a toaster because it will toast things for us. We buy it also because of what it looks like, what it says about us. With an electromechanical object, like a radio for instance, you have a mixture of physical mechanical things and electronic things. But with computer things, there isn't that necessarily connection between physical things and virtual things, things on the screen. So you can actually design them so that what we see on the screen can be completely unconnected to what's going on inside the computer. One of the things I think we need is a clear mental model of what it is that we're interacting with. So for instance, HyperCard, which was an early scripting system on the Apple, had a very clear mental model which was of a stack of cards. You need to know where you are in the system. You need to know what you can do next, where you can go, and what's going to happen when you've gone there. And I think that the Star interface and the Apple Macintosh interface were very, very important in this way, that with a menu at the top of your screen, you have laid out for you all the possibilities. And it's very clear to see how you access them, what you can do, and what's going to happen. How can we make sure that people don't have to think about how to interact? A very nice example of this, I think, was in Quark Express, where you could zoom in a very simple way. You just didn't think about it at all. You just did it. Driving a car is another example of something that, having learnt it, we do instinctively. We don't need to spend very many mental cycles on the actual driving part. We can talk to our friends, we can think about what we've got to buy on our shopping list, and we can do them all simultaneously. When we design a computer-based system or a machine, we're designing not just what it looks like, but how it behaves. And we're designing the quality of the way we interact with it. And this is really what interaction design is. It's designing this quality. When I move my mouse, for instance, does it feel sluggish? Is it nippy and sprightly? If you're playing a game, the kind of interaction and the kind of attention you're prepared to give to it is very different from if you're programming your central heating, for instance. If you're designing a fire alarm system, the last thing that you want is something that's just kind of difficult to find your way around and intriguing. You want it clear, unambiguous, direct. Interaction design needs a fusion. It's not just visual, it's not just sound, it's a mixture of things that happen over time, visual things, sonic things, moving images. And we need to draw on existing disciplines to make a new type of design, which is interaction design.
You needed some kind of device that you could select objects on the screen to tell the computer that's what you wanted to do something about. So we got some funding in the early 60s, I think it was from NASA, and we set up an experimental environment with about 6 or 7 different kinds of devices, a big tracking ball and a light pen and things of that sort that were available at the time. And as we were setting up the experiments, I happen to remember some notes I'd made in a notebook about this size, as a matter of fact, some years before, when I was a senior in electrical engineering. The little wheels will only roll as far as the axis of rolling direction, and they slide sideways. So what I began to see is they would just if you had a wheel like that and moved it around, that it would roll only as far as you went in this direction, irrespective of how many sideways movements you made. So I wrote in my notes here about putting them, 2 of them like this at right angles to each other, and that one would then always be measuring how far you went north and south and the other east and west. And easy to convert that to potentiometers and things so that the computer could pick up that signal. That one was put in the experiments, and it just happened to be winning all the tests. So that became our user interface pointing device. And somebody, no one can remember who attached the name mouse to it, and we can picture why, because it was an object about this big and had one button in the test to use for selection, and we had the wire running out the back end towards the user at the time, and was sitting there, somebody says, it looks like a one-eared mouse. But so we all just started calling it a mouse. Incidentally, Logitech Corporation, that's the largest of the world manufacturers of mice, had just recently sold its 500 millionth mouse.
The thing that we went to PARC to do, which makes our position somewhat different than some of the other interaction designers think of, is that we really wanted to do a supporting science. My first boss at PARC was Bill English. English was really the engineer who built the first mouse. It was Engelbart's idea, but English really built it, and so jointly it's the two of them that really invented it. So English is trying to look at alternate devices. He was pretty busy. I agreed to help him do the experiments. I modeled each one of the devices, so I had the empirical differences between them. And then I was trying to figure out how numerically to account for why those differences occurred. And so I did a model of every device. Now the most interesting model was the model of the mouse. The mouse, because you can do input on output with it, you can draw with it, really advances what you can do with computers. The limitation in the device was not in the device, it was in the eye-hand coordination system of the human. And what that meant was that the device was nearly an optimal device. The hand was showing through the machine instead of operating the machine at a loss. And so if you were to introduce this on the market, nobody's likely to come out with another device that beats you. Having some notion of the theory of this thing gives you some structuring of the design space. And so my design for that was, okay, here's a pencil, and it's stuck onto an eraser. You had a basket of mouse designs that you had tried at one time before that based on various metaphors to try them out. But as soon as I could explain how to structure the design space from this theory in a matter of days, back with 3 beautiful designs for a thing that could beat the mouse with progressively more radical assumptions. One of them was just a mouse that was better shaped so as to allow these muscles to come into play. One of them, the next more radical one, was a puck, and so you could hold this little knob. And then the most radical one was a pen-like device. This is sort of my ideal model of how this works. It required a good designer to actually do the design. But what we could do is we could help structure the design space so that the movement through that design space is much more rapid than otherwise. So the science didn't design the mouse, but it provided the constraints.
I was hired by a publishing company that Xerox owned at the time to manage a project they were doing with PARC to learn the system that was being built there, take it back to the publishing company, and have people at the publishing company use it. I wrote a letter of resignation and said, you know, this is not a project that you should be doing, period. That letter found its way to Bob Taylor, who was running the computer science lab at the time. I sat down and spent some time with Bob, and he basically said, well, why don't you figure out what it is we should be doing? That was when I started working with Larry Tesler. The way we went about the design was to actually work with the editors at GIN. I went back, I spent several weeks with them and put them in front of an imaginary display with a real keyboard and a real mouse, and asked them if they could sort of walk me through imagining using that hardware to edit. And once Larry and I hit on this idea of having people talk about how they would want to do the work they did today, but with a new set of tools, The design itself became pretty simple as well, because there was a methodology that came out of it. Somewhere in one of my notebooks in Xerox, there is a bar napkin with one of the first desktop metaphors. We had this very intuitive text editor, and we were working on what we thought was going to be a very intuitive page layout system. But we were still stumbling, all the users were still stumbling around things like filing and printing and deleting. As I was thinking about this, it just occurred to me that there was no reason why we couldn't use the same approach and build an environment that allowed people to move documents around in the same way that we were allowing them to move text around inside a document. And we didn't call it the desktop, we called it the Office. We actually called it the Office Schematic, was the first name that it had. But it was very similar to the desktop metaphor that we see today.
We got in this pattern, Bill and I, where he worked nights and I worked days. And we overlapped, morning and night. Tim Mott and I did the same thing. We worked 14-hour shifts, Tim and I, overlapping by an hour both ends. So we could tell the other guy what we'd done. We shared 1 alto between us. So I'd work for, 12 hours, and he'd show up. I'd tell him what I had done, and then he would just pick up the code I was doing. He could work on the code another 12 hours. Then I'd come in, and he'd show me what he had done, and we'd brainstorm user interface, and then continue. We did that for days on end and get the thing working. With Bill, I would run user tests all day. It was easy to find subjects. Every new Apple employee had never used a computer before. Well, not all day, but I'd run 3 or 4 tests during the day on whatever Bill had given me the night before. Then I'd give him a report at the end of the day and say, here's what I learned today, why don't you try this, why don't you try that? And we would talk about ideas, and then he'd go off and go home and spend the night programming and come in the morning with a new version for me, and then go home and go to bed. And that's how we developed the first Lisa user interface specification. There was a dominance of people from HP working on the Lisa team. They had already gone to putting a row of buttons at the bottom of every window. So it was a big menu tree that you had to sort of keep in your head. And you'd have to walk down and go like edit, insert, you know, that sort of thing, and walk down the hierarchy. Anyway, I thought this was just horrible modes. That was the interface. No, guys. People can't keep all these menu hierarchies in their heads, and everything needs to be apparent. So one day I said to Bill, Bill, why don't you try something different? Why don't you try moving it to the top of the screen? So he went home, and he came in the next day, went directly to Steve Jobs' office to show him first, I think, and then came over to us to show us. And in one night, he had developed the entire pull-down menu system, everything. I mean, he hadn't just moved it to the top of the screen, which was what I'd suggested. He had gotten the idea of, as you scan your mouse across the top, each menu would pop up, you know, without you having to, like, you know, click each one, which is what was in my head. And they would ruffle, you know, as you went back and forth and appear, so you could scan them all. I went, oh, right, this is what we want. We want everything to be apparent. He'd come up with highlighting them as you moved your mouse back down inside them, command shortcuts. He thought up the whole thing in one night. It was, I can't imagine what happened that night.
My first major work that I did for Apple was porting over the UCSD Pascal system to the Apple II. And when I hired on, they hired me as the application software department. They saw software sort of as a necessary evil to sell the box, which is really what they were building. Then after that, I became the graphics and user interface lead on the Lisa team. So for that, I wrote what later became the QuickDraw graphics routines that all the applications use. And I got to design a lot of user interface stuff. What I've got here is a binder of some Polaroids that I took. These are just mock-ups. These aren't finished product. This is a prototype that I did showing people about choosing a tool first. And so that was our first tool palette. Choose a rectangle tool. Now when I draw, I'm laying out a rectangle, and when I let go, nothing changes. It's already there. Here was a notion of a folder with a menu at the bottom of it. And that didn't work so well. Problem is the window might be narrow and you couldn't see them all. Here was the first of the pull-down menus. Now, the advantage of putting the menus at the top is you had the whole height to deal with, and you had always the full width, regardless which window was using that. you got a second benefit, which is you started a kinesthetic feel of where that item was, that it's, oh, it's over here someplace. And so you could actually start reaching for it before you even thought about it. And that's one of the reasons that the pull-down menus were such a success. The width of the title is much less than the width of the menu. So as you slide across here and these flap out, it feels like they're all here, but really they're all grossly overlapped because there's a lot more area. You're getting a lot more area out of it than you really have. I think that the way that user interfaces get better is by the designers watching people trying to use them. And it's very humbling. I remember when we were working on the Lisa user interface, we'd have a half-silvered mirror between two rooms. And what we would do with each piece of software we were working on, we would hand it to them and say, well, here's the task. And ask them not only to try to accomplish the task, but to give us a stream of consciousness. Tell me what you're thinking about as you do it. Sort of mumble to yourself. And many times we discovered things from that that we would not have discovered without that.
When Microsoft approached us on the project, it became clear in the early conversations that it wasn't kind of the typical just design us a mouse and get it on the market, but they wanted to design the end-all mouse, essentially the mouse that was going to be better than anything that preceded it. Quick model making was a key. I think we probably built, 70, 80, 90, 100 different foam models quickly. The first step was looking broadly to make sure that we were exploring all the possibilities of what a mouse could be. So going out and talking to users about how they use their mouse, observing them, watching them, kind of looking at the nuances of computing, led us to certain beliefs that then we built prototypes of and tested. We thought by building small mice that were symmetrical, so say a small round mouse, that you could actually capture the mouse in your fingertips like you capture a pen in your fingertips and create a high degree of accuracy. We were very surprised when we went off and did testing with prototypes against other mice, tests like tapping tests and maze tests and a variety of tests that Wilbur Planck actually had set up and Jane Fulton, that although they felt more accurate, they failed in 70% of the tests to perform better than a more traditional elongated mouse. And what we discovered was that having the mouse kind of fully encompassed in your hand gave you more control over it, even though the sense was that your fingertips would give you control. It was the hand and then the resting posture of the rest of your arm on the table that actually allowed you to perform more accurate and quicker accuracy tests. Moving the ball forward on the mouse was the biggest change that we made. Mice had been driven from a manufacturing point of view, kind of coming from the PC world, so it looks like a PC, coming from a world of we need to be able to make this cheap. And the cheap way to make the mouse is with the ball in the back. And watching the motion of people's arms and the observations, realized that moving the ball forward would allow you to basically have a shorter motion to accomplish a fuller motion up on the screen. If you look at a mouse today on your desktop, most of them have the ball, although maybe not always to the front, but forward of center. And that's become kind of the standard for mice.
I'm going to start with the definition of interaction design. Focusing on design for people. So that's a person interacting, acting on the world, and getting feedback from the world. The interaction designer has 3 questions to answer. They're all how do you questions. The first question is how do you do? How do you affect the world? And I think of a simple choice there between handles and buttons. So I can deal with the world by pushing buttons, or I can grab a hold of the world and manipulate it, or grab a hold of a product and turn it or twist it. This is the handle world. It's the world of continuous control. The buttons are the world of discrete control. The second question is how do you feel? This is how do we get feedback from the world. There I like McLuhan's distinction between what he called fuzzy or cool media and
hot or distinct, cool and hot. Early television was a cool medium with its fuzzy images. A book with careful printing or a gravestone with carved type is hot. It's immutable. You cannot touch it or change it. Cool media draw you in. This is the handle and the button. Finally, the third question is, how do you know? And as we design interactions with computers in them, it's very difficult for the user of those products to know exactly what they're going to do. And a nice dichotomy is deciding whether the user needs a map to see an overview of how everything works. Or maybe the user just needs to know exactly what to do moment to moment, and a path is sufficient. Do this, do this, do this, do this. So those are the three basic things that happen in an interaction. A human, a person we're designing for, does something, and we provide affordances. As designers, we design the way that the machine gives feedback. Finally, it's the question of what kind of knowledge do we expect of our users? Can we design good maps for them to hold in their heads? Can we design the emergency procedures step by step, how to do things? So that's the first definition of what it is we design as interaction designers.
The big difference with Mac OS X was that was completely design driven. We focused on what we thought people would want and what they would need and how they would interact with the products. We made sure we got that right, and then we went and saw and tried to determine how you achieve that technically. We had this idea of a time-based operating system where we were using not only the two dimensions that you have on the screen, but a third dimension of time. One of the criticisms that people had about the Mac OS ever since the beginning was dragging a disk icon to the trash to eject it. That was something that we knew confused new users, because normally if you had a file that you wanted to delete, you would drag it to the trash and it would be gone. And now we're asking people to do the same thing with this very valuable disk where they've got all their information on. You make the same gesture, and rather than deleting it, it just ejects it out of the computer. We did something very simple that solved that in Mac OS X, and that was just based on time and what you're doing at the time. Or when you select an object that can be ejected, the trash can actually changes to an eject button. A second way we used animation in the interface was to provide hints for where an object is going and where it came from. And you see that in the dock. When you minimize a window, the window will morph into the place where it rests in the dock. When you restore that window, it comes out of the dock in the same way. So if I really want to have 100 things in my dock, I can do that. The trade-off I have is that things, it gets harder and harder to see them. So we thought it was much better to let our users make that decision than for us to try and impose something on them. But we also came up with an idea to address that. So as your dock gets smaller and smaller and smaller, it becomes harder and harder to differentiate between the different things in the dock. So we came up with a way for, as you roll over items in the dock, they can magnify. On the visual side, where things were dark and gloomy and square and beveled, we wanted to make them light and fun and fresh and colorful. And when where there was something that was square, we wanted to make it round. And where there was something that was just kind of chunky, we wanted to give it a very fluid expression. Some of the designers had magazine ads for liquor. They typically have a glass with ice cubes in it. And if you look in there, you see all these great specular reflections and highlights. And that's actually where we drew a lot of the inspiration from.
I actually was meeting with a guy in the executive office of the White House. And he said, "Let me tell you what I want. I want all of this capability of your beautiful Alto. I want it in half your briefcase." And he went and grabbed my briefcase. I said, "Well, this briefcase, that's hard." And I said, "Well, you think that you're typical of people?" And he said, "Yeah, let me tell you, my job as a senior member of this establishment here is to go to where the problems are And I want a computer, a full computer, to carry with me that has the communications, has all the capability of the Alto, but downsized for me to carry. And frankly, with the Grid, we were trying to do the impossible. Nobody had ever crammed that amount of electronics into such a small space. That half the briefcase was hugely tough. Everybody was worrying about how to get all this stuff inside and keep it cool. Remember, in those days, the IBM PC didn't exist. Well, we went with the 8086. We were the first people to use the 8087, the mass processor. We were probably one of the biggest bubble memory users ever, and everybody was saying, whoa, you know, bubble memory is real, you know. The small screen that we had to launch was an amazing screen that was done for us by Sharp. Those of you who have not seen electroluminescent panel will still, when you see one, say that's the panel. It was gorgeous. It was like a jewel. It was this wonderful, beautiful orange. Now the software. Huge, huge thing was making a set of common in the middle. We're going to need a spreadsheet. You're going to need a text processor. You're going to need a terminal emulator. You're going to need a sort of email thing. And that common code was incredibly well done. You know, this is a big deal about how to make this thing, you know, what you see is what you get. Maybe not, because we're not really interested in print medium. We're interested in formatting the messages. We're interested in making the software right to make sure that we had as much of that code to do those things as possible, and that the interface is exactly consistent. Now, in other words, you pulled down this menu and clicked on this thing, it did exactly the same thing. We had good times with NASA because we worked directly for the astronauts' office. You know, and these guys were actually going out to the stars, you know, with a grid. Emergency navigation for the shuttle was a huge, big thing, and I think we got a lot of good publicity for it.
So when I was at Grid, we did the laptops, we did the Grid Pad. These are all sort of larger devices. But when we were selling the Grid Pad, what struck me is I had a lot of people love the product. I had numerous people came up to me who were using it for some vertical application. They said, you know, if you could only make this thing smaller, and I could put my personal data on it, it would be really, really clever. I'd really like this. And it struck me that in the future, that everyone would be carrying something in their pocket. I decided to leave Grid because I felt that would be the best way of getting a sure footing starting a consumer electronics company to focus on portable devices. And that was the beginning of Palm Computing. So one day I was sitting with one of our board members. He says, well, do you know what product you should be building? And I kind of lied. I said, yeah. But I hadn't really sat down and thought exactly what would I do if I started from scratch. But I said, yeah, I know it. And he says, well, why don't you go figure what that is? And I said, well, that means we have to do the whole thing. We have to do the hardware, the software, the operating system, everything. I'm going to do it from scratch. He said, well, what else are you going to do? And I said, all right, great. So literally in a day and a half, almost one evening, I basically laid out the premises of what became the Palm Pilot. We had a whole bunch of accumulated knowledge by now, having worked on the Zoomer and the Newton and General Magic products, but no one had ever said, how would you put it all together? And so, you know, I came up with the 4 premises. I said, well, it had to be a certain size. And I made a model that very evening out of wood. And then I wrapped it in paper. And so it was a pocket-sized device. And I just sort of figured out what would be practical and what we could do. You know, that was one attribute. I picked a price point of $299, which was very low at the time. Another goal is it had synchronization with the desktop built in. Up to that time, everyone thought synchronization was this add-on. And I realized that that was the application. And the last thing we picked was that it had to be fast. And the metric we used, it had to compete with paper. We realized that our competition was paper. The software guys came back and they said, well, we can't do all the stuff you want to do in software with that slow a processor. And I said, sure you can, because when we were at Grid, we had a more sophisticated operating system which ran on a slower processor and it was fast. So if we could do it back then, I don't want to hear about it. We can do it now. And sure enough, they were able to do it. I mean, we made a product that was really very fast. So those 4 things, the price, the size, the synchronization, and that sort of user expectation model were the 4 design criteria for the Palm Pilot. One of my design goals for it was that there would be no weight cursors. You know, we don't want those. That's a crutch for bad design. Another one, I said, we're not going to have any error dialogues, and especially ones where you ask the question of the user and the user doesn't know how to answer it. So we came up with a bunch of design criteria like that, where I used it as a way of sort of like solving a lot of the problems I saw with PCs. I said, well, you know, these are stupid. Let's not do that. This is stupid. Let's not do that. And so it was a good formula. In the end, it worked.
The essence of what I'm trying to bring to the personal computer, you should probably think of it as a tablet mode. And that is a mode in which you can hold it in one hand, use it with the other, and do the interacting with just one hand. And the pen clearly is the precise and most exciting tool with which to do that in the current generation of tablet PCs. That tablet mode allows you to be more mobile because you can interact entirely with one hand. So do something else with one hand, use the PC with one hand. But combining graphical sketches with textual capture is really something that you can only do with the pen. Very difficult to do all that with a voice, impossible to do it with just a keyboard, and difficult to do it with a combination of keyboard and mouse. That said, just the ability to literally capture your thoughts and see them the way that you thought them, essentially, that's the first layer. The second layer is to be able to transform those into other data types. And the most obvious example, the one that everybody thinks of as the gating factor with regards to tablet computers, is text, is ink to text, and the ability to essentially of the system to recognize your handwriting and translate it into ASCII or you know, whatever text format you want it in. Something that you only find out when you're using a pen as a text input device and also using it as a pointing device is that the interleaving of pointing and writing happens so fast that you really are able to compose as quickly with a pen as you can with a keyboard. And this isn't a function of handwriting recognition being an equal number of words per minute. This is a function of handwriting recognition plus correction plus pointing plus, you know, placing your cursor, selecting, dragging text around, reformatting, undoing. You've got all this combination of things that you're trying to do, some of which is text input and some of which is pointing device. And when you can do that in a fraction of a second back and forth between the activities, it's really astounding.
Palm OS was developed in 1995, basically. Actually, before that, we had developed at Palm a handheld computer called the Zoomer, which was a competitor with the Newton. We had a 320 by 240 pixel screen resolution. When we moved to the Palm OS and we had 160 by 160, that was even smaller. Jeff defined the resolution and he said, well, can we design an operating system on this? I said, sure, of course, no problem. And then afterwards I think, okay, ooh, this is going to be difficult. Basically we said with this size of screen, you can't apply rules consistently. Forget about being consistent, forget about having rules. You have to just do the right thing. There are actually only very few features in any application that you use very frequently. Things that you do very frequently, you want to have right on the screen, you want to have instant access to them. You want them right there. If you think about the way your desk is organized, and you have some things on your desk and you have some things in your drawers. And well, why is that? Because you want to access them very frequently. Imagine if you had your phone, you put it in a drawer, and every time you had to use it, you had to pull it out of the drawer. Well, it might just be one more step and it might be 1 second, but it would really drive you crazy over the course of a day. And how many times do you add a new phone number versus how many times do you delete a phone number? And I think you could argue, well, you add pretty frequently and you delete fairly infrequently. So therefore, we put the new button, the new address button on the screen, and we had the delete address hidden behind a menu. Think about your stapler and your staple remover. In my case, my stapler is on top of my desk and my staple remover is in a drawer. On that size screen, instead of having a whole row of buttons, you can basically fit 4 buttons on the bottom of the screen. And the question is, well, how do you decide which 4 buttons are on the screen? The conventional wisdom at the time was to go away from mechanical buttons because you have a computer, you have a screen and a digitizer. So that gives you the flexibility, so you should not have mechanical buttons. But so, well, I can have 1 button that you press and it shows your calendar, and I have another button I press that shows my addresses, and then we said, okay, that does it. That's the closest to coming to sort of a aha type of moment. One piece of advice I give for people designing for the Palm OS is If you can really understand your customer, think of the one thing they want to do most frequently, and then make that a one-step process, then I guarantee people will like that product.
I first became aware of the original Palm, the original Pilot, it was called, and I can clearly remember, I said, this looks like what I could really use. It was very clear that there was almost no good way in a small handheld device to put text in. Hawkins really had the idea of simplifying, meeting it halfway, doing some sort of a stylized alphabet that a computer could recognize quite easily, where you don't lift your stylus off the screen. That was the key insight, and then you make these your alphabet, and so people could get pretty good at that. And it didn't take much training. You could pick that up in an hour or two, and you're off running. So it captured some devotees, but it was still a very small percentage of the population that could even be bothered doing that. It was but it was enough to get the business going. And we met Hawkins. He came and said, what we really need is something much better from a user's perspective. This was nearly 20 millimeters thick. A goal of making it half this thick, 10 millimeters, was high on the list. And it was clear that there was a big need for customizing and for protecting and for identifying the product. There were two identical rails on either side, and it allowed the initial stylus that shipped with it, or accessories such as the pen and act as a stylus, or all sorts of cases, from soft cases to hard cases, would snap onto the other side. I remember Jeff not knowing, he says, well, okay, we're going to send the Trio out there with a keyboard and a graffiti, and the people are just going to vote. And it was quite clear, it was 2/3 or more started picking the small keyboard. And it turns out that it doesn't seem intuitive. Once you show it, people say, how can you possibly type on that? And then I just type out a little paragraph for them like this in a matter of seconds, and they say, wow, you get pretty good at that, don't you? But it sort of proved that there could be some sort of a little thumb keyboard and it would be effective. It kind of broke through some barrier, thumb barrier, if you will. Overall, I don't believe that you'll end up with one standard as far as in I/O, in and out kind of interaction design in these products. I think that just the market will segment more and more.
The adoption of a fresh technology ordinarily passes through 3 stages. First, to enthusiast users who actually love and appreciate a technology in an aesthetic way, who enjoy exploiting it. And the fact that it may be a bit difficult to use actually adds to the fun. The 35mm cameras used by the astronauts in the 50s nearly required a PhD in optics to operate them. Now, once enough enthusiasts have their hands on a product technology, sooner or later, one of them will say, I can use this in my work. And they get a clever idea about how they're going to do something highly practical with it. In the case of the 35mm camera, when it went from very expensive Exotica to being used by professional photographers and serious photographers, but broadly used, suddenly it stabilized. The viewfinder was in one place. You exposed by pushing with your right index finger. You wound the film with a lever with your left hand. You focused in a particular way. So there was a stabilization of the controls, even though they were all highly manual. After a product has built up big enough volumes through this business phase, that's when suddenly one begins to reach a price point where it's practical for consumers to buy it. And so in that stage, the priorities for the product have dramatically changed. And one thing that we always see is that most of the important controls become automatic. So now, to follow our camera analogy, today you buy a 35mm camera, it has, if it even has film in it, it will read the film speed automatically and set the exposure automatically and set the flash automatically. And everything is done, and actually a chimpanzee can take a pretty good photograph with today's 35mm highly automatic camera. The enthusiast wants that product to say, exploit me, look at my capabilities. The business user wants the product to say, look at the productivity I can give you. Here's how I'll change your activities. The consumer wants the product to say, look at how I fit in with your style. Here's who you are if you use me and enjoy my capabilities.
So in about 1995, Kodak came to IDEO in order to understand the future of digital cameras. And really, there were two main insights. Digital cameras live within a product and service ecology. George Eastman created Kodak by understanding that you've got your box brownie camera, but you press the button, we do the rest. He's turning the development of film, which was a messy hobby with chemicals, into a mass market consumer thing. But also, secondly, you've got to understand why is it that people take pictures in the first place. You really need to go back to underlying user motivations. Photography is a means of self-expression, it's a means of recording information, but more than anything, photography is a social enterprise. It's about building social capital, it's about sharing ideas. So having got this vision of where digital cameras might be going, you need to actually begin to implement that. And so we decided to tackle what a digital camera might look like. What we understood immediately was that where cameras previously were purely about capturing an image, a digital camera would suffer from the challenge that you were not only capturing images, but you'd have to review images, share them with others, possibly delete images, make a voice annotation, email, or even order prints from the camera itself. So we needed to create some sort of information architecture or interaction architecture, some extensible series of rules that would allow not just one camera to be designed, perhaps a whole series. And a second choice was to decide how we would communicate that. Of course, we could have just created a booklet, a report which would give very clear instruction. But instead, we decided that we wanted to make something more experiential, a user experience prototype, we called it. It was a big box with a security camera jammed on the front, a very fat umbilical cord going to a Macintosh Tower computer, and it was all running Macromedia Director. And here, in a matter of a few weeks, we crafted a user interface on a camera, allowed you to take a picture and delete it and send it across the room to a TV. And what was interesting was that it really expressed not only what was going on, what were the features and functions, but how it felt. Kodak took this prototype and only about 8 months later turned it into the DC-210, which was one of the best-selling cameras of the time. So it was a remarkable way, I think, to influence a camera that was already in development and begin this first step towards this future of new digital cameras.
My name is Kenji Hattori, and I am a software engineer, and I was developing the photo stitch. Stitch assist mode in camera come from the camera engineer, and they thought that the camera can assist the software. The first image will remain to the left side of the LCD, and the user can adjust the camera position to match the remained image. And the remained image and the current image is transparent, and the user can match the image, the current image, with the previous image.
I am an interaction designer, and I've been working for Canon for more than 8 years. And when I was involved in the development of PhotoStitch, I was working in the human factor department. I started with version 3, development of version 3. So to make version 3, I tested version 2, and also I checked version 1. I did a very formal usability testing using in-house people as a test subject. The most biggest problem with the old version of Word, structure was not visible to the user at all. And there were too many steps to stitch. The biggest change I made was using the tab user interface instead of step-by-step. But we had a lot of argument since at the time I developed this software, it was not so popular to using tab user interface for step-by-step operation like 1, 2, 3. We decided to put the animation to reinforce the text messages. And after I tested this, we found this kind of animation was really helpful to beginners. So it describes how to drag a photo to the other photos. I got an idea mainly from the observing people, how they manage to do something or what's the cause of the problems.
In the early days of the kind of Silicon Valley, we did a lot of design of screens and input devices, and kind of they're mostly general purpose things. When it got real exciting was when those things came together, when we were really making products. So now you're talking about special purpose things where you could do controls. You didn't have to do the general purpose solution. You could do specific controls for that specific instrument. Products will start to be smart enough and integrated enough that they will react to us. That's the thing I think is different than the toaster and the blender. The toaster and the blender sit there not knowing how we are, waiting for commands. I think information appliances, highly technological appliances, will kind of know we're there, anticipate what we want just from the way we act. That's what hasn't happened yet, and I think it's coming. Yeah, one of the really big things in the future is basically sensors and effectors. All the technology, the IC technology and nanotechnology and all the kind of small stuff, I think it's going to first manifest itself in these sensors that we have everywhere. RFID tagging is probably the first thing to come that everybody's talking about. The dream there is that for inventory control that a truck can drive by and you can have a sensor that registers everything that was in that truck. I mean, I guess there are security advantages of that as well. From the early days of interaction design, when we were really working with displays and controls on computer screens, to the day when it's gotten much more complex with the experiences that people are having. I think the way that affects design firms is design firms have to be much more user-centered. We used to kind of work on things assigned by our clients, and now we have to decide actually for our clients and ourselves what's worth working on, and that's really about understanding people and their needs and what they value as a society. In the old days, we used to prototype objects, so we had machine shops and we would prototype objects, and we still need machine shops. But the other thing you do, if you're going to design experiences and design services, you have to actually have new prototyping tools to explain to people what it would be like with this new service. We're using more storytelling, taking improv classes and acting things out. Everybody knows how to use some kind of quick and dirty video process so they can tell a story. People are becoming cartoonists so that they can do quick storyboards. The combination of understanding people and telling stories rather than understanding technology and building devices is kind of what's happened in the design business.
If you look at the culture of Apple, it is a company that's had 25 years of building personal products, and in the last few years they've had a very, very astute individual at the top that can really dictate in many ways or arbitrate what's good and not good. That culture, that management capability that's at Apple makes it unique in this industry. I think to answer the question of why the iPod is so great compared to the competition, if you break it down, they started very slowly and they built it up over the years. They started by acquiring the technology. They acquired a company called SoundJam to build iTunes, and this was back in, I think, 99, 2000 or so, and they turned that into the iTunes franchise, starting first on the Macintosh. The ability to generate the music, to let the user rip that music? How do you get that content at at the beginning? That's the root of the problem. You got to have it. So Apple invested in iTunes and built that up and improved it over the years. In 2001, Apple shipped the first device that synchronized with with iTunes. The two were deeply integrated together. Now keep in mind, the iPod is very simple-minded in terms of at least what the device does. It's very smooth in what it does, but the screen is very low resolution. It really doesn't do much other than let you navigate your music. The simplification that went into the design of it was very well thought through, and the capability to build it, is not commoditized. It's very curious, right? Because the iPod's been out there. It's been essentially unchanged in terms of its core software design and user interface design has remained unchanged for about 3 years now. And then in 2003, Apple launched the iTunes Music Store, and this again was something that did not exist at a level that was mass marketable. Apple was the first to make it mass market capable. They applied that Apple magic to make that possible. They took their time in doing that, and it was remember as well. It took Apple a couple of extra years before iTunes for Windows was actually developed and shipped. And so again, they're practically moving in slow motion, really, if you look at it in hindsight. But the industry has not been able to match it, and so now today Apple's moving into color displays, and eventually they'll move into video as Moore's law continues, giving us its bounty.
One of the first precepts of Electronic Arts of why interactive entertainment was going to be as big as traditional entertainment themes of music and video. We believed that play was a core human value, and even a core mammalian value. We use an analogy that lion cubs learned to hunt and fight by playing together. So it all started out with Electronic Arts imagining that people using technology could have the same kind of fun that lion cubs have tussling in the savannah. In the taxonomy of gaming, there are also 3 ages of gamers with 3 psychographic needs. You got the pre-adolescent, you got the teen, and you got the grown-up. The kids up to adolescence, they really want only 2 things in life. One is muscles, and the second is freedom from the control of their parents and teachers. You ask a 10-year-old boy, why do you play video games? The answer is, at school, my teacher always tells me what to do. At home, my parents always tell me what to do, or maybe my older brother or sister. Video games, no one tells me what to do. They want to experiment with having huge amounts of power. They want to feel that within they're earning the virtual power with their hands. So they want physical mastery. They want to run over tacklers, and they want to throw blockers aside. They want to take the quarterback and, plant him into the ground up to his waist. Now, teenagers, the job of teenagers is to explore identity. So teenagers like playing story games. And they want to have parallel lives, compare and contrast, because by the time they're 18, 19, they've got to pick a direction. The digital virtual reality can give them a chance to play multiple lives. So adults play games for mental stimulation, and because now they're stuck in a rut, they need to kind of get out of it. So mental stimulation and self-improvement. Kids play flight simulator and say, "Did you see that explosion I caused? That was awesome." And adults play flight simulators because they say, "I was going to have to pay $2,500 for flight school, but for only $50, I now have gotten my flight rating up to this."
We do a lot of prototyping. If you come to our space, we've designed our space to be like a big project room. And as you can see, we've gone to a very small desk area, which allows us much more lab and tinkering space in the back. And it's great because people are thinking much more about the we space versus the me space. So there's a weekly meeting where we're showing proof of concept models There's brainstorms that happen on a regular basis. And we'll also try to get out to the toy stores on a weekly basis. And then, of course, having kids in to play with is just, you know, one of our cornerstones. We'll sort of commission 6 kids or so, keep them in, have them in once a week, and try new things with them. Try things that we're working on, or try things that we bought and tested, or anything. And we call it a focused play group. We're not behind the one-way mirrors. We'll have a couple adults that they'll have the same adults for the whole time, so they'll start to build a little trust. Sit down, ask them a lot of questions, just what they're into, what's interesting, so they get a conversation going, and then try some new things. We've done a lot in the games, and that's all about social interaction, and for us, getting kids together around, or families together, not around the TV, but in the family room, sitting around the table, sitting on the floor kind of thing. And that's kind of a wonderful feeling. We did the Fib Finder game, which is it's a funny lie detector that tells if kids are telling the truth or not.
Is Sky this first guy in the universe?
Well, yes. Let's ask the Fib Finder to make sure.
What was fun about it was when we tested it, seeing the girls 8 to 11 or something, what we call the high giggle factor of just this, you know, it's that slumber party laughter and just having such an enjoyable time, because the questions that we wrote were sort of open-ended to find out new things they would find out new things about each other. So it's more challenging for the boys, but that challenge then could be a bigger opportunity. We're doing a boys version of the Fib Finder called High Voltage, where again it has a fun, unique lie detector. This one gives you an electric shock, well, a mild one, but well, it's just a fake one, but it feels like it. But it's all the proper kind of questions that would get boys thinking and chatting.
Purple Moon.
People had tried, certainly before Purple Moon, to do girls' games. Girls have this predisposition towards narrative play. And in fact, narrative construction, you know, we talk about constructive play. We think about hammering things and making snow forts and stuff. Well, that's a pretty boy form, although girls do those things. Girls are much more interested in the kind of constructive play where we make up a family or we make up a couple of sorority sisters. We had the vision from the beginning that we wanted to make a transmedia property. A property that had physical manifestations, as in the little dolls of the characters that we sold, and with the magic stones that came with the Secret Paths series. What we wanted to do was to create a world with characters that girls could affiliate with, where girls could have emotional rehearsal space for the social lives that they led, hoping that they would find that they had more flexibility, that they would have more elasticity in their own lives, and also because it's really fun to think about, gee, how would that have gone if I'd done it a different way? So you could always rewind, make a different choice, see what happened instead. We looked at the inner fantasy world. We learned by interviewing girls that they usually place that kind of activity in a more natural sort of romantic setting.
Dear Rocket,
a part of the interactivity that you had to really probe the game to find was that you could always go to the lockers and look in a character's locker. The child would welcome you. Hi, I'm Jessie, you know. But the contents of the locker, including journal entries and pictures and stuff, would change depending on how you had played the game so far. But we also had a strong web initiative where girls could contribute story material to us and work over the story material that they were getting in the CDs.
This is a really good day.
We wanted to be sure that girls had access to the characters in the stories and that they could contribute. So on the website they would write articles for the newspaper, or, you know, send email to the characters, and certainly talk with each other and collect treasures and trade treasures. So it's a very social space.
As a kid, I spent far too much of my time making models, you know, little aircraft, tanks, When the first personal computers came out in around 1980, I bought one of the first Apple IIs, but I got totally sucked into the software side of it, especially simulations, the idea that you could build this virtual model inside the computer, and not only was it kind of a, a model of the static structure, but it was also a model of the process. At that point I just kind of decided, that's what I wanted to do. I wanted to learn to build these models, and that's when I started pursuing it as a career and kind of went from there into the game industry. The Sims has reached a level of success that is just amazing. At some point, I think we realized that it was like the best-selling PC game in history now. And a lot of that really is, I think, related to the community design around The Sims. The game itself was interesting and compelling, but the community that built up around The Sims really is what brought it to the level of success that it currently has. Well, actually, The Sims probably has more sex than most games out there. I mean, it's PG sex, and it's more, kind of titillation than realization. The Sims is basically in a social space, and it's about the way these people relate. And they can get married, and they can have kids. They can hang out in the hot tub together. They can play in bed. So when I first play a game, the very first thing I'm dealing with is a 5-second kind of feedback loop between the computer and the player. And that's usually the control structure. So the controls have to be understandable, and it's actually got to be fun to kind of use the controls. With a game like The Sims, the very first level is, how do I make my character move around and interact with objects? And you learn that, I click on an object and it comes up with a menu and I select an item. Then, once you know that, once you can move your character around and interact with objects, you start noticing that they have needs. That they'll, they need to go to the bathroom, they need to eat, they need to have social interaction with other characters. Each one of those has a failure state. If they don't eat, they'll starve to death. If they don't go to the bathroom, they'll soil the carpet. So then, at that point, you start learning to keep all of their needs in the green. Once you've learned that, you've actually bought some free time that you can then start pursuing the economics of the game. So every game has kind of this, these overlapping loops of interaction. I'm compressing a large set of possibilities down into a few algorithms of computer code. When I hand you the computer code and you start running it, you can then decompress it in your play experience to this rich set of possibilities.
I joined NTT Docomo 5 years ago to launch this service. Now I have more than 32 million subscribers, and I also have more than 12 million Java phone users. The toughest thing I had to overcome was how to migrate internet way of thinking with this legacy telecom way of thinking. Handset can represent your taste. That's why we are always making a really heavy effort for the tiny details. And also the shape, how round it should be, is very important. To keep antenna, sometimes very important, because in the lifestyle, some people using like this. We have to coordinate whole the value chain from the handset to the content. Because to have this kind of software here means you have to have a content provider for this, you have to have a network service to support this, and finally to have great design phone is very important. User interface of the phones should be easy enough for everybody. We requested our handset vendors to have an iMode button to launch iMode service, and also 4 direction keys like this. We developed more than 180 icons. Each icon shows some messages, like heart mark always shows you some kind of love messages. When I first introduced iMode phones, the capability was just to browse the web and to send and get receiving emails. With the second generation, you started to download color graphics, you started to download ringtones from the network to the phone. And with third generation iMode phones, thanks to Java capability, you can customize the function of the phone. So some people customized their phone as a karaoke machine. So to see the script here and to sing a song, practice.
LiveWork is a service innovation and design company founded in 2001. Started with 3 partners, Lavrence Lovely, Ben Reason and myself, Chris Downs. We've grown up professionally designing for the web. The generation before us of interaction designers were dealing primarily with interfaces, but we're wired slightly differently because we're thinking about networks, and when you go beyond that, you end up at the service.
When we set out creating a service design agency, we were really surprised that there weren't other companies out there. So we realized we had to build some of the components of service design ourselves to be legitimate. We realized we needed to have a language that spoke about services in a native way. We realized that we wanted to have a connection to the academic community so we could test our thinking in a rigorous way. And we needed some big clients that would actually buy service design projects.
So the big difference between designing services to designing products is services exist over time and are experienced through multiple touch points.
We've developed what we call service ecologies as a process to actually map and start rearranging and designing the ways actors operate within a system.
So one of the methods we've had to develop here at LiveWork is evidencing. Because services don't really exist, they're intangible, we've had to find a way of communicating the experience of the service. So evidence really is about faking the experience. We make props or artifacts that describe the impact that that service has had. So for example, developing the Orange Premier service, we had to make the packaging that the service would be delivered through, the letter of introduction, the box that would come in.
And we had a really great opportunity working with Fiat and the Interaction Design Institute of Raya on a project about services that surround people's cars and looking at community use of cars. We asked questions about who, why, what, when, how are different actors and objects involved in the wider context of car use. We chose one touch point to work up to try and create a kind of a one-liner for an issue. So we weren't really coming up, this project wasn't service solutions, but there were issues around access to mobility, recording time, community rules. And each of these issues is expressed as an image, a photographic image, as a one-liner to try and get across what was going on, what we were trying to influence within Fiat. We picked up a phrase in Italy, which is rapido, piccolo, economico, which is the kind of the guiding principles of prototyping. How can you do it fast and cheap?
In service design, it's not just about getting in tune with the customer. We have to consider all the other different stakeholders in the mix. So that could be the business perspective, the brand perspective, the technology, the operations, the relationship between the business and competition or industry commentators. There are so many different stakeholders, and that really what we need to do is use the same sort of empathic techniques that we use to understand customers to understand those different perspectives. Juniper were an online bank. What they really needed was some clarity and a point of view about what they could offer as a service provider. One of the techniques that we used was to get people to draw their money. We had already asked them to sort of walk us around their house or their work and identify things that they associated with money. So they were already in that sort of frame, in the right sort of frame of mind. But what we wanted to do was sort of help them flip to the other side of the brain and express more emotion, the emotional connection with money. We started with a sort of broad range of observations. And from those observations, developing insights, and then from those insights, crafting those insights into a framework. At some point, that framework became a sort of 2x2 of the sort of psychographics of consumers. And the dimensions of that framework were short-term to long-term view, and low engagement to high engagement with managing money. That framework in itself became very powerful as a decision tool within Juniper, because not only did it give them a perspective on who their potential customers might be and on what their behaviours and their needs might be, that we could start to take a look at the competition and who the competition were going after and how they were addressing these customer needs. And from that framework, you can start to generate, hundreds of ideas. And then not just leave those ideas sort of floating around in the ether, but ground them very quickly into prototypes at many different levels and modalities. But through iterative prototyping, you work towards the most effective solution.
No medium is right for everything. And I think people have learned that for certain kinds of things, the internet kind of communication is really wonderful. It's used all the time. And for other kind of things, it doesn't work. I mean, shopping is an example. If you're buying a book and you really know the title, you know the author, and you just want to order it fast, something like Amazon is wonderful. You type it in, you're done. It's coming. When you're buying clothing, it's a different thing. Looking at pictures of clothing on the web is not the same as feeling them on the racks. There are several different ways that we interact with the world in general. And so take three primary ones. One is manipulation. There are things, and you move them around. You use your hands. You look at them. You do things to them. The second is locomotion. You go places, and that's how you get around the world. And the third is conversation. You say something, another person says it back. So that involves two parties and so on. If you look at computers, all three of those metaphors are present. So the early ordinary time-sharing system was conversation. I type something in, it typed something back. The Xerox Star, the Macintosh, that whole line of things was manipulation. In the shift from the internet to the web, the metaphor shifted more than the technology. So I used to say things like, I'm going to retrieve a file from somebody else's computer and bring it up on my screen. So that's manipulation. I retrieve it, I bring it up. Now I say, I'm going to go to their homepage. I'm doing exactly the same thing. I'm retrieving a file from their computer and I'm putting it up on my screen. But I've shifted my thinking away from doing things to moving. One of the problems with the web, typically, has been that it's a read-only medium. You can see things, but you can't easily change things. That's getting better. There are a lot of technologies being developed for that. And I think as those technologies develop, the place metaphor becomes less appropriate. And we're going to see an interesting amalgam come out of those. There are those who understand the network, they understand routers, they understand servers and all that kind of stuff. I think there's a much larger population who doesn't think that way. They don't even know it's there. They think about sites and pages. So they say somebody has a site. If you say, well, is there a server? Where is that site? It's, at somebody.com. It's not in Virginia. It's not somewhere physical. It's at somebody.com. And the geography of those sites has to do with what pages are connected to what. And it's a particular kind of geography, which again is completely orthogonal from anything having to do with networks and routing and servers and all that kind of stuff.
Said, oh, we should just go out and start a company. And we developed this thing called PageRank, which lets you determine the importance of pages based on the links to them. You start with a web page. Actually, we used to start with my homepage. And you just follow the links. So it's like you're surfing, but you just follow the links from that page. And you keep doing that until you have the whole web.
You record everything as you go. And you do it at a rate much faster than a person would, like 1,000 web pages per second or something.
Since we started in '98, we started with about 30 million web pages, which was a good number. That's a lot more than you can read, right, in your lifetime. Now we have over 3 billion items. Just in the last, a little over 3 years, we've increased by a factor of 100. And those things, require work. They require smart people, lots of computers, and all sorts of things.
When you look at our usage, we went from 10,000 searches per day, just as we just came out of Stanford and started the company, to over 100 million now. So that's a factor of 10,000. I designed the page, and I wasn't about to spend a lot of time on it, so I just put a search box in there and the search button and the logo, and that was it. Eventually, we added a little bit of stuff about the company, but it was still quite small and compact. And we realized how powerful that was, because it actually matters when you go to the homepage of a search engine. You don't want to spend a lot of time trying to find the search box. You really want people to come there and then be able to right away use it for what they want. And after that, we made a conscious decision that we were going to, in fact, take things off that page.
So we've added a lot of services. It's a design challenge to add services without increasing the complexity.
In our case, we really insist on initially deploying a new service like we did with images. We will deploy them maybe off the advanced search page, and we insist that they get a lot of traction on their own, sort of without the benefit of that top page promotion. And if they have user pickup at that level, then we will go ahead and bring them up as a shortcut, a convenience to users.
We like to say we're focused on the ultimate search engine. And the ultimate search engine would basically understand everything on the web. It would understand exactly what you wanted. It would give you the right thing or the right things.
A portal for a site like the BBC says, we can find you exactly what you need. We think that we've probably got the answer within the BBC, so we're going to make it as easy as possible for you to get to that answer. It's a site with over 1 million pages of content. Realistically, for a site of this size, we need some anchor points. So we introduced a toolbar which was effectively an anchor point for the user. So that stayed on every page on the site. In visual terms, we gave it almost browser language, almost widget language. So it's a grey toolbar, so that it becomes almost part of the browser. It's the browser of the BBC environment, if you like. It means that it doesn't conflict with the information on the page. It also means it doesn't get mixed up in there. So we wanted to make sure that the language of the site said that it was trustworthy, said that it was professional, but at the same time was at least somewhat engaging and intimate. That's one of the reasons why the clearly dominant main promotional image right at the top of the page is always a very personal image. That image effectively is the soul of the site. So what we have is we have this very elegant and professional structure which is then supported by a very intimate image. So into the BBC homepage we've built what we call digital patina. The digital product of the homepage can adapt itself to you. Just like something you use gathers a patina with age. If you go and buy a pair of Doc Martens, they're not actually that comfortable. Once you've worn them every day for about 6 months or so, then they start to mould themselves to your foot. And they are comfortable. And in fact, they're the most comfortable shoe you can find because they've moulded themselves exactly to you. Depending on where you go when you go to the BBC homepage, then slowly that page will adapt itself to your visits. There is an algorithm in there which means that every time you visit it, it will change the intensity of the colours of certain areas, so that the areas that you most recently visit pump up slightly in intensity.
I'd worked with Philip on another project about 5 or 6 years ago, and at some point he decided he wanted a website, and he asked me, this is at basically in the middle of the dot-com boom, and he asked me, who should I get to do my website? And so we went around to various companies, agencies in the city, and basically no one was willing to talk to him for something that was less than $1 million job. And so I thought, what should we do? And I thought, well, maybe I'll take a stab at it. We had this idea of a number of spectrums spectra that represented these various attributes. At some point, we started looking at analog devices for navigating the spectrum. So this idea of scrubbing across a particular characteristic, or surfing across a characteristic to see if there's something there you like, and basically giving someone the full representation of this is everything that's here. So you're not going to find it anywhere else if you don't find it here. So start looking, start browsing. Well, I drew this picture of what I wanted this thing to look like. It was just a bunch of little colored bands, and they were and you basically a single line connected the bands, each one of which represented piece of music along. And so I had this picture, which I thought, I like this. We had these colors representing various categories of the music. So yellow might be opera and red might be symphonies. That was the first design. And when we ended up with this kind of a density problem, that there might be 10 things sitting at the exact same spot on a characteristic, we said, okay, we actually need to get rid of the colors, and we'll use some sort of density gradient to say that black is represents a lot of things here, and a gray, light gray represents nothing here. And so we ended up with this kind of monochromatic thing, which is, well, I think, much more it's much more appropriate to the music too, I think, because you look at it and there's so little to look at. It really allows you to focus on what you're listening to. The most satisfying things to me are those things that are pared down, so everything is focused on that one thing. That is what, to me, is the ultimate pleasure, is that kind of just this very, very laser sharp focus.
Let me introduce the story behind this Music Bottles project. Originally, I wanted to present the weather of Sapporo City, my hometown, to my mother. I wanted her to feel the weather forecast of today. So now you hear the sound of the birds singing. This means tomorrow becomes clear day. And if you hear the sound of rain, tomorrow becomes rainy day. Okay, let me start talking about basic interactions. This diagram shows a very simple structures. Interaction requires two key components. One is the controls through which people can manipulate access to the digital information. Also, it's very important having external representations that people can perceive to understand the results. So this diagram illustrates the graphical user interface. The main medium of the representation is the pixels on the computer screen. That's intangible. To control these representations, graphical user interface provide generic remote controllers like a mouse or keyboard. Here is Abacus, the most simple form of the digital computational device. It's physically represented so that user can directly touch and manipulate and control. So this diagram illustrates the tangible user interface. The key idea is giving a physical form, tangible representation to the information and computation. This tangible representation is tightly coupled with computation inside of the computer. But this representation is physical so that it also serves as a control mechanism so that people can directly grab and manipulate. By doing so, they can control the internal computation or digital information. But one of the problems of physical representation is you cannot change the shape or color or form dynamically using current technology easily. So that we usually couple tangible representation with intangible representation like a video projection or sound.
So here's a coin. Yes, mechanically it has certain properties. It's hard to copy, it fits in your pocket, but it has three other interesting properties, and they're pretty much social properties. It has value. Yes, it's written on it what the value is, and its size and shape denote that to some extent, but the real idea of value is not a physical thing. It also has country. It belongs to a nation, but most of all, and strangest of all, it has ownership. And the ownership isn't represented on it at all, but we totally accept it. And it's mostly defined by the distance it is from you. If I'm holding it, it's mine. If it's in my pocket, it's mine. If I place this far enough away, we start questioning whose it is. We don't think about this as a pointer to money. It's not a tag for money. It is money. If a physical object that you can recognize has a pointer to an application or a folder, a container, in a computer space, then perhaps the physical environment is just as real as the screen environment. In fact, they are the one and the same thing. Any object picked up physically, which you can see has been augmented with digital information, can be taken to a tool, perhaps a reader, or to a screen, and you can see the same object in its other representation, and it is only just another representation. There's a bulldog clip here, it's got a tag on it. What does that do? Well, bulldog clip's kind of an abstract thing. You need to attach it to something to have any meaning. So I put a microphone on it, I put a message in, and I put a bit of paper on, and I say, John's letters from John, and I leave it out for somebody. I started now to make my own icons and my own physical objects on the machine. All you really need is an object, which represents the person that you keep, that becomes the item you pick up and take to different tools to find the things. Here we have a little plastic frog, and it's got a friend's name on it. If we take him to the computer, it opens up the computer representation of him, i.e. a folder. Inside that folder are a series of files. I can now pick up a piece of video sent to him and drag it into the folder and take the object off the computer. I now have put a piece of video into a small plastic object. What's important to me is that there are different items which sit in an environment and you can remember what their properties are. You can see the potential of an action, you can see what the potential of, say, how far something might move. And it doesn't actually matter what the object looks like, as long as you can remember easily after seeing what its behaviour is.
When I got to Apple, the idea that began to obsess me was how we might include pictures and also images or movies. In about 1988, I attended a conference where I heard a paper on dynamic documents that was presented by Michael Mills. And it so happened that I managed to persuade Mike to spend his sabbatical with us. So he came, and what began was a really wonderful series of, I think, 6 years that we worked together, and became some of the most seminal work contributing to what we all know now as QuickTime.
I'm Mike Mills from the QuickTime team.
In those days, we referred to it as dynamic icons. They were really that small. They were about ½ an inch big.
Golly, I'm so impressed.
So Mike Mills began a series of illustrative prototypes. The little movies that we put inside documents often used the original Muybridge illustrations. Jean-Louis Gasset, Vice President of Engineering, said, "Now I know why my grandmother wants a computer." I had never even thought of my grandmother using a computer, let alone why it would captivate his grandmother and why what we had done with movies meant that.
Factories use the best machinery that money can buy.
Now, looking back, of course, he had a lot more insight than I did, which was that it began to change what a computer and all the documents on a computer were about. Something moved, something came to life, something played.
Direct manipulation.
And that began a series of 4 or 5 years of building successively on the first illustrative prototypes to bring more and more control and playback capabilities into what now we all know as QuickTime. For example, when you open the document, does it just sit there as a picture? How do you know that's a picture? How do you know it's actually a movie? Well, we had to put a controller there so that you knew something would or could happen. We could actually imagine different styles of controllers, different mechanisms, just a very subtle thing like how would you start and stop? Would you just start and stop? No. Would you like to go faster or slower? At that point in time, when we shipped through developers, we realized that the QuickTime Kit was going to be for people ultimately who didn't need to have all sorts of fancy control over video. So I think that the sophistication of your products have to actually match the sophistication level at that time of the consumer base.
We've just recently finished building a series of prototypes that look at how weight sensing can be used to get partial information about people's activities in the home and then translate that into interesting or intriguing displays. One of the pieces that we've just about finished is called the drift table, It's a small table about the size of a coffee table that has an aperture, a kind of porthole on the top of it. And through that you see slowly drifting aerial imagery of Britain. So it's as if you're looking through a window down onto the landscape. The intention is to make it almost as if your room is floating above the landscape. If you put things to one side of the table, the imagery starts to drift in corresponding direction. We've built a table now that contains a high-end PC, a bunch of hard drives, load sensors, stamp chip, and so forth. And all of which sits within the table. But when you put the cover in, it's just an elegant object showing an image that drifts by, and it works. And so we can take it and give it to people to try in their homes, and that's what we're doing. Another piece that goes along with the drift table, there's actually another two pieces. One is called the key table, and it's again uses weight sensing. But here the notion is that when you walk in your front door, you'd find this table and you'd use it to put your keys or your mobile phone on. And what it measures is not the weight of those things, but the energy or the force with which you throw them down. And then it does a kind of crude mapping between that and your emotions. So the notion is that just as you slam a door hard when you're upset, the idea is that you'd also throw your things down rather hard if you're in a bad mood. We take the energy with which people put things on the table and use that to control the tilt of a picture frame that hangs on the wall. So that if you throw things down, the picture goes skewing way off base. And then the next person coming in the house, the idea is, would look at that picture frame and say, uh-oh, somebody's in a bad mood, I'd better tread warily today. The third piece that we're developing is called the history tablecloth. Again, it uses weight sensing, but here we're interested in how long things have been on surfaces in the house. The history tablecloth works by looking at when things are placed on certain areas of a table. They simply mark how long they've been there. And the longer something's been there, the more that an underlaid electroluminescent pattern starts to glow.
The kind of pleasures that you get from reading a book or watching a film, I think the kinds of things we're trying to explore in relation to products. How can you design products that provide complex and complicated pleasures?
We spend a lot of time looking in newspapers for the odd story that's about a real thing that's happened that's just unexpected, and we constantly collect them continually.
We came across a pair of underwear on the internet called personal protection devices, and there was a male and a female's version. They were fairly normal, but they were covered in silver-coated nylon, and they were meant to protect you from radiation while you're using the computer. And they can't really do that, and they are placebos. I think an example of that is the GPS table, a small table with a global positioning sensor inside it. And on the top surface of the table it has a display that shows its position, its exact position. But if it's indoors, it can't communicate with the satellites, so it usually just says lost. By being lost, it asks the owners to deal with that in some way. Do they take the table out into the garden and let it communicate and fulfill itself?
So Lorna, in her everyday world, she found when she thought about the table, she became humbled by it, in that suddenly, in an everyday moment, she would suddenly think that she's really, really small, this tiny person on the planet.
I guess we're like pandering to the bad side of people, the side that is complicated, contradictory, irrational. And we're really curious if you filled up a room or a space with objects that reflected those values, how that material world would look different from the material world that surrounds us now. One of our students is working on a project at the moment called Utility Pigs. And the idea is that when you're born, your parents buy you a pig and some of your DNA is put into it, so that in future life, if you need a spare organ, that can be taken from that pig and your body won't reject it. But this pig becomes a very special part of the family, and rather than putting them in laboratories or on farms, in his project the pig is brought home. But one of the things he was looking at the problem of smoking. If you smoke near the pig, you might harm it. And there are two things to that. One is because you have the pig, you can smoke more. And the other thing is that because of the pig's meaning, you don't want to smoke near it. But he designed a small fan device. It was like a megaphone, and when you were smoking, you put the cigarette into it, and it would filter the smoke. And the reason he did it was because he said he wanted to smoke, he wanted to be with his pig, and he wanted it now. He wanted it all.
digital tools today are simply too complex, they're too expensive. I have to buy all the upgrades. If I upgrade my OS, I have to upgrade the software. And these little bits of money are okay, but they're bothering me now, you know? And I'm so bothered now that I want to change this somehow. And so, how do you change it, I was asking myself. And well, to do something impossible, and that is to rewrite all the software out there as simple, freely available, extensible modules that live on the web. In my group right now, we have one unit focused on the Treehouse Studio, and that's the infrastructure of different applications. We have Mark, who's being the key architect behind the underlying layer.
Treehouse Studio is what we're calling Linux for visual art.
I have a bunch of undergraduates working on different applications in that suite. One is Mariana working on a photo editing application.
Mostly I've been doing a bunch of filter transformations.
We have Annie working on a drawing application.
It's designed with very simple code that's flexible so that people could look at the code, learn from it, and then later build on top of it.
We have Jessica working on a new version of Design by Numbers.
Design by Numbers is a programming language for teaching how to program in the visual realm.
Also, we have a whole separate area of things fitting into the Open Atelier universe, a gallery system to have online exhibitions being done by Alan Rabinovich.
It's a system that allows the users to very quickly and efficiently sort of publicize their work.
And a cafe. And so in this system, I can meet people online in a restaurant. We can order food. We can eat different food. We can click on it and eat it right now. So that's lifting off the ground with Rick Rose.
In the future, hopefully, I'll have waiters around to serve the people.
Also, we have another physical bent to things. Pat's working on a very flexible display system that can display any geometry.
It's using an array of 14 iMacs. People can use it so that they can display their work either on one iMac or cluster them or on the whole thing.
We have Quinn working on a physical conduit.
My project involves making it easier for artists to create simple input-output devices for their projects on the computer.
I believe it's important for there to be a moment of crystallization in this global creative community that we have, which happened in something like the Bauhaus. Is it possible to build another inspiring moment in digital media? There has to. Otherwise, we should just all stop, pull the plug.
I have to use 3 computers for Macintosh, Windows, and Unix. So I have to use 3 mice on my desktop, and also 3 keyboards. So this is very, very complicated. And I suddenly think about why I have to use 3 mice. Because when I'm dealing with physical papers, I only have to use 1 pencil and use 1 pencil for different types of sheet. If the real world is connected, particular document, a particular paper is connected to a particular pencil, the world is very, very complicated. So I invented the pick and drop information. This is very simple metaphor that can connect to computers by picking one object from one computer to dropping on another computer. So I'm very accustomed to use chopsticks. Using chopsticks, and I can pick up food from one dish to another. So I want to do the similar interface in a computer environment. Using a pencil, a pen stylus, and a pickup icon, for example, on one computer. And then icon disappears from the screen, but you can virtually hold the icon with your stylus. And then you can approach to another computer screen surface, and then tap it. And then the information is transferred from one computer to another computer. So this is active object. So I'm transferring information, not just a still picture to characters and maybe active object, movies, or maybe simulation, animation, anything can be transferred. I can point. So now my PDA is connected to the TV set, so it becomes remote commander. I can change volume, or I can control channel. There is RFID chip here, and there are RFID readers here. So just put these 2 devices within proximity, and the network connection automatically established. Then I can transfer data freely between these computers while I'm picking up information from one computer. And then I can go to another network computer, such as other notebook PC, and do it again, I can simply put this proximity. Maybe the small computer, such as a cellular phone itself, can be acting as a pointing device for the nearby environment. So you can make a cellular phone call, and also you can attach nearby screen, and then pick up some information, and then you can drop on another computer.